Good evening, dear colleagues. Our team will present to you the work related to the use of simulation modeling in school education.
We represent the Department of Zoology and Animal Ecology of Karasin-Kharkiv National University. The pedagogical experiment was carried out on the basis of the Kharkiv University Lyceum, where I was working as a teacher at the time.
Our motivation for this work stemmed from the recognition that the traditional schooling often focuses on teaching students to work with systems that are not the ones they eventually have to deal with in real life. Students are learning how to get the right response from simple deterministic systems that contain complete information about themselves, that respond to changes in our influence in linear way, step by step and mostly predictably. However, in real life, the systems that surround us behave completely differently. So we believe that alongside traditional teaching and traditional types of tasks, we can use interactive models in the educational process. In many features that you can see here, such models can better prepare students for real-life challenges. Our inspiration for building this model came from David Attenborough's documentary film, Life on Our Planet. There's a moment where Attenborough is sailing alone on island in the Palau archipelago and says that when Palau banned fishing in certain areas, it eventually led to an increase in the number of fish caught per day. We became interested in why this happens and used this idea to build a model which was later offered to school children. In fact, the theme of protecting fish stocks involves or can be described by different types of training tasks. We can ask students to calculate the catch under conditions where we increase the fishing effort with the condition that the catch increases accordingly. And this is how school assignments are usually structured. Instead, we propose to optimize the catch in conditions where the system response is nonlinear. Here, you can see the construction diagram of our model and its main input parameters. Here we see 6 bordering water areas. A certain amount of fish can live in each of them, and its amount represented by n parameter. This amount is determined by the value of k, capacity of the area. In each area, fish reproduce, which is regulated by the parameter R, biotic potential. Parameter M describes the speed of which fish are distributed between water areas, and U parameter determines what part of fish stocks we take in the case of organizing fishing in a certain area. By setting different usage patterns for these areas, we identified 13 patterns where 0 represents no fishing and 1 represents permission to fish in this area. The model is built in such a way that the work cycle is performed step by step in each cycle. We determine how many spawning fish are produced. Так, sorry. Знову цей слайд.
Слайд сначала, а я вырежу все.
Да-да-да. The model is built in such a way that the work cycle is performed step by step from the initial number of fish in each cycle. We determine how many spawning fish are produced, how they are distributed between sites, how many spawn in each site. We can observe how many fish are harvested from each site, depending on the fishing pattern chosen, and how many remain in each site afterward. We see certain parameters at the input. Next, this cycle is recalculated many times, and at the output we get the dynamics of both the number of fish in general and the catch. Next, we can see which input parameters for which of these patterns can ensure a stable catch for a long time. We designed and created this model in R language. It is quite small and can be downloaded from the link on the screen. We calculated what the sustainable catch would be at certain intensities of reproduction and migration under different conditions of intensity and patterns of catch. Our findings revealed that certain side distribution patterns, such as pattern 3 and 4, with selective harvesting from 2 out of 6 fishing sites, resulted in the highest and stable long-term catch values. We offered students of grades 10 and 11 at the Kharkiv University Lyceum 2 types of tasks: the traditional one and work with an interactive model. This educational experiment took place under the conditions of quarantine when the training took place remotely. Students were randomly divided into 2 groups, and one of group worked with descriptive learning material and the other one with an interactive model organized using spreadsheets. Links to both types of tasks are on the screen. We obtained about the same scores on the final test, which tested the students' understanding of the material, like how exactly the catch depends on the exploitation of the fish areas among those who worked with the descriptive narrative and those who worked with the models. However, it seems to us that our experience has shown that it is possible to work with this approach in the future. Unfortunately, our work was interrupted by a full-scale Russian invasion of the territory of our country, and right now Kharkiv is also under attack of Russian missiles, but we hope that this work will be continued, and this report marks the initial step forward. Thank you for your attention.